Hello, this is a video to go along with the exceptions area of the book in the first chapter. And when you write programs, you're used to getting syntax errors, which is when you make an error in writing your program, like leaving off colon or different things like that. The other type of error you're going to see is logic errors, and logic errors are errors that happen when you're running your program. I have a file here that demonstrates the points in the book, and the first one to do is to demonstrate a syntax error. And so you'll see for I in range, and if you uncomment this, what PyCharm does is it puts a little red squirrely brace right here, and if you put your mouse over it, it tells you the error. It says a colon expected. So it tells you what type of error it discovered. If you run this in Python itself, which looks at your language and tries to interpret it, you'll see a different error, and this is the one the book shows. So you'll see that it says you're typing into what file, line 1, and then it repeats the line that has the error, and it puts a cursor where it thinks it found the error, and then it says you have a syntax error, invalid syntax. So those are both syntax errors. They're detected before you ever run your program. What PyCharm does is it's smart enough to look at the structure of your program to detect syntax errors before you give it to Python. And that's what the little squigglies are. So let's go ahead and comment. The way you uncomment and comment code, which is useful in a lot of programs, and PyCharm is true, you hold down on Windows, you hold down Control, on a Mac you hold down Command, and then type a slash. And so if you select a whole list of lines and do that, it toggles commenting the lines or uncommenting the lines. So that allows you to have code that you basically turn off by commenting them out, is what that's called. Now logic errors are when the program does not perform correctly when you run it. Sometimes this results in a situation where the Python interpreter will just stop the program and raise a runtime error. And the next is an example of that. So it says uncomment the next line to see the example. So we'll do slash, the command slash, because I'm on a Macintosh. And what we're doing is we have the math module that we've loaded already, and we're going to ask to take the square root of -2. And the math module will not let you take square roots of -2. If you get into more advanced math, the result of that is called a complex number. It's not a normal number. So Python just calls that an error. So let's go ahead and run this. And you'll see down here it says traceback. And traceback will list all the methods that you're in. We're not in a method, so it's empty. And then it says what file you're in, so you get the complete path of the file. And then you get the line number in your file that caused the error. And when you get these type of errors, type of errors, you can click on this path and it takes you directly to the line in your editor, which is very useful. And then it says in module. Module is a keyword for your current file. And then here's the line that has the error, and it says value error, math domain error. Now, unfortunately, many error messages you may have already noticed, you're not sure what they mean. So math domain error is a general error that means you passed a parameter to something in the math module that is outside the range of numbers that is designed for. So the domain of the square root is only positive numbers, so that's what it's telling you. Okay, so let's comment out that line. Now these types of runtime errors are called exceptions. When you're a beginner and you see these exceptions, you see them as fatal to your program, and maybe you want to rewrite your program to avoid it happening, obviously, because it would just stop your program. But many languages allow a program to intercept these errors and do something different, so your program can either continue to run, or even maybe you just want to raise a more English readable error when you detect that before you stop the program. So let's check out this code. This is how you can intercept a runtime error and do your own thing. And one of those things you might do is continue running. So this uses what's called a try-catch block in the industry. In Python, it actually is the syntax try, colon, and you put any code you want indented in the try thing, which is your normal program sequence. And then after that, you put an except block, which is considered to catch the error. So if any error occurs in the try area, the except will catch it, and whatever code you write indented in the except block is what will happen instead of it just causing a runtime error. So in this case, we're going to input from the user. I have an error there, so I'm fixing it up. So we input from the user, and we convert that to a float, and then we actually print the square root of that. So if the user types a negative number, this will cause an exception. But because it's inside of a try block followed by an except, the code here will run when that happens. And it's basically going to print the original number out, and then it's going to print, I am printing the square root of, and it's going to print the absolute value of that number. And then down here, it's actually going to take the square root of the absolute value. And then, so it'll not cause the error. So let's go ahead and run this. And so we'll input a number like -2 again. And it says your input of -2 was a bad value. I am printing the square root of 2 instead. And notice the negative sign is gone. And here's the square root of 2. So that's the try-catch block. And the next example is you can, when you're doing a custom program, you may have reasons that you want to cause an error and your program to stop because you've detected some problem that has to do with your custom requirements of your program. So in this case, I ask a user for input. I have some errors there too. I don't know why I have float twice. It won't hurt anything, but it's redundant. So in this case, we ask the user for their income, and our custom requirement is that their income should not be negative, because that doesn't make any sense. So if we detect that the income is negative, we use a special statement called the raise statement, and you say raise and runtime error, and in parentheses you put a string, which is whatever message you want. And when we run this, let's comment out our previous example. And then we'll run this, and we'll put my income is minus $1,000, and you'll see it causes a normal Python error, and it has all the characteristics. It says the file and the line number, but then it says raise runtime error, your income can't be negative, and then it actually prints the runtime error, and it has your statement that you provided to the runtime error. And so that's a rundown of exceptions, and that's it.